will now proceed with the next section, which is about multi-way branches. In C++, a branching mechanism selects one out of a number of alternative actions. That way, when we are writing programs which needs to address different conditions which would affect the flow of our program, we can therefore use multi-way branches. And an example of that is the if-else statement. Branching mechanisms can be a subpart of another branching mechanism, which means that we can place another branching statement within another branching statement, which would give us, in this example, a nested if statement. In C++, a nested statement is a statement that is a subpart of another statement, such as your if statement, and embedded with another if statement or an if-else statement. When writing nested statements, it is normal to indent each level of nesting. Here's an example. If we are going to write if statements, our code would look neat and more organized if we observe the practice of indenting our code, such as this one. That way, our code is easier to read and therefore easier to understand and debug. Here's an example of an if-else statement with an if statement. As you can see here, we have the main if statement, and under which we have the corresponding if-else statement, which is basically a nested if statement. Talking more about nested if-else statements, we must use care if we are going to use nested if-else statement. For instance, we have the following programming problem. We would like to design an if-else statement to warn a driver when the fuel is low, but tells the driver to bypass the pit stop if the fuel is close to full. Otherwise, there should be no output. If we are going to convert our solution into a pseudocode, this is how it's going to look like. For example, we have the first condition in which if the fuel gauge is below 3/4 of our fuel capacity, then we will evaluate another condition using this if statement. For instance, if the fuel is below 1/4, then we will issue a warning that our driver needs to refuel. Otherwise, if our current fuel is greater than 3/4, then there's no need for our driver to stop. If we will look at the pseudocode, it's actually quite straightforward in relation to the problem that is given. Thus, if we are going to convert this into an actual C++ code, this is how it would look like. As we can see here, the program looks fine. As you can see here, we correctly represented our pseudocode into an actual C++ program. But actually, if we are going to run this program, we are not going to get the output that we expect. Why does it happen? It's because if we are going to run this program, what C++ does is it pairs the else with the nearest previous if, such as this one. Which means, although our original intention is that if the fuel gauge reading is less than 0.75, then we are going to do this statement. Otherwise, if our vehicles still have enough fuel, then it will simply tell the driver that there's no need to stop since we have enough fuel. But of course, that is not going to happen. If we are going to run this program, this would actually lead to a logic error. It's because, as we previously said, what our compiler will do is that it is not going to pair this else statement with the first if statement like we intended to do it. Instead, what it will do is it will pair this else statement to the nearest previous if. Therefore, we are not going to get the correct answer or output from this program if our fuel reading is more than 0.75. So how do we fix this? We fix this by using braces. As you can see, that is one tricky part of using nested statements if we are not careful. So therefore, using braces is quite useful. Just like parentheses in arithmetic expressions, braces in nested statements are also useful. It tells our compiler how to group things. So, if we are going to fix our previous example by the use of braces, this is how it's supposed to look like. For example, let's take a look at our C++ program. As you can see here, this is where we placed our braces. Thus, we can expect our program to be correct. As you can see here, we placed two different scenarios of our program. What we have here is the version without braces, as what we have seen in the previous slide. And this one is the version that we fixed. Let's try running this program. Okay, for instance, I'm going to input 0.25. Okay, as you can see here, this is where the problem occurs. As you can see here, without the braces, we expect that our program is supposed to warn our driver that our fuel is running low. But instead, it says that the fuel is over 3/4 and there's no need to stop, which is obviously a logic error. Now let's proceed. We also have what we call multi-way if-else statements. An if-else statement is considered as a two-way branch. 3 or 4 or maybe more branches can be designed using nested if-else statements. Of course, it can be possible, but at times it may not look appealing. So therefore, we need to find ways to organize our code and to make it look neat. Here's an example. For instance, we have a number guessing game with the number stored in the variable called number. Then the guess in the variable guess, and of course, if we are going to implement this, this is what we are going to do. For instance, the following nested statements implement the hints for our number guessing game. As you can see here, we are presented with three possibilities. It's either our guess is too high for the number, or it could be too low for the number, or we guess the right number. Therefore, if we are going to translate the three conditions into an if-else statement, this is how it is going to look like. But of course, we've already mentioned about organizing our source code, especially if-else statements, using indentions. Notice that the code on the previous slide doesn't look great since it takes up too much space, and of course it might look confusing. But if we are going to use indenting, those extra spaces can be gotten rid of, and therefore we will have a more organized source code that looks neat and easier to read. Of course, this is just actually a very simple example on how we organize our code, but later on, as you write lengthy source codes for large programs, you will actually find this practice quite helpful, especially when you are working with a team of programmers. And if you will notice, in this example, we actually have three conditions. But there will be instances that the final condition would be the last option or would be the last possible option for our program. So therefore, it tells us that when the conditions nested in an if-else statement are mutually exclusive, then there will be no need for us to include the final if-else statement, such as this one. In this case, we can simply get rid of the last Boolean expression since it's quite obvious that this would be the last possibility for our three conditions. So, what is the standard syntax for an if-else statement? In this case, a multi-way if-else statement would have the following syntax. As you can see here, we have the if keyword followed by your Boolean expression enclosed in parentheses, then your statements. Same also with the succeeding else if statement. Simply use the else if keyword followed by the Boolean expression enclosed in parentheses, and of course, as many else if statements that we need. Then finally, the last else statement, which would close our nested if-else statement. Here's another example that makes use of nested if-else statement. Of course, this example is also given to you as a sample program. So I would like you to explore this program by yourself. That way you would understand how it works, as well as for you to learn how nested if-else statements work. So I would like you to try this one for yourself. So for instance, in this example, we have the following. Let's say we would like to write a program for a state that computes tax according to the rate schedule. For instance, there's no tax for the first 15,000 of income and 5% tax on each dollar from 15,001 up to 25,000 and 30% if it exceeds 25,000. And this is how the program would look like. Okay. So here are the preconditions that we mentioned a while ago, and implementing that into an actual C++ program, we have the following. Of course, it's going to require us to enter our income. Then we have the following equation. As you can see here, we are actually using the function tax, and we provide our input as argument. So let's take a look at the definition of the function tax below. So as you can see here, this is the actual implementation of the pseudocode that we had from the previous slides. We have a corresponding condition for income less than 15,000. So in this case, there's no tax. Then for income that is above 15,000 but less than 25,000, then there's a corresponding tax of 5%. And finally, we have the last part in which the income is greater than 25,000. Just like from our previous example, since the condition is mutually exclusive, there's no need for us to put the following expression. Instead, we can simply cross them out and perform the necessary statements. So that's how it would look like if we are going to apply nested if-else statements to solve the previous programming problem that was given. So if we're going to run that, let's use the same input that they have in the example. Let's say I will put, so as you can see there, we have the following output. I would like you to try some other inputs by yourself so you can figure out how this program works as well as the details of our source code. So how do we refine if-else statements? Notice that we have the following line. Specifically, this line can be found in the second condition of our nested if-else statement. This one actually. This if-else statement is, of course, it looks lengthy, but we can make it simpler and replace it with the following. Instead, we can simply put one condition. Instead of having net income is greater than 15,000 and net income is less than or equal to 25,000, we can simply indicate net income is less than or equal to 25,000. Why is this so? It's because that any amount that is greater than 15,000 would have already been handled in this condition. It's because the first condition will only handle amounts less than or equal to 15,000. Therefore, any other amount exceeding 15,000 but less than or equal to 25,000 is already understood that would fall under the second else if statement. So therefore, it can be shortened and we now have the following. Next, we proceed with the switch statement. The switch statement is an alternative for constructing multi-way branches. For instance, the example that we have determines output based on a letter grade, which we will see as we go. For instance, we have the following scenario. If we are going to use branching statements, then each letter grade will have their corresponding branches. And for example, grades D and F would have the same branch. If an invalid grade is entered, then a default branch should be used. this is how it would look like. We have example 7.6 written this way. As mentioned, these are the corresponding branches given a letter grade. Thus, we have the following. As you can see here, this is also equivalent to a nested branching statement, only that this time we are going to introduce a new method called the switch statement. We will talk about the details of this as we go. First, let's take a look at the details that was mentioned a while ago. As you can see here, for the letter grade A, we will have a corresponding branch for that. For the letter grade B, we also have a corresponding branch for that. Same with the grade C, and in the case of D and F, they would have the same branch, and of course, for any other input that is not included in A, B, C, D, and F, then we will have a default branch for that, which we would explain later. For instance, let's run this program. Let's see. For instance, I'm going to input A. As you can see here, it follows the logic of our source code. Let's try that again. Let's say I'm going to input D. As you can see here, it says not good. Then I'm also going to try again, and this time I am going to input F. And as you can see here, D and F would follow the same branch. Now, let's look into the detail of the switch statement by looking at its syntax. As you can see here, we have the keyword switch, and then we have the controlling expression, which in this case, the variable grade. And for each branch, we call them the case. As you can see, it looks similar with the if-else statement as far as branching is concerned, but if we are going to use switch statement, then they are now called as case. And of course, for each case, we will need to indicate the constant that would represent the branch that needs to be executed if such case is satisfied, just like in our source code here. Okay. We have the control expression, which is grade. Then we have the following cases. In this case, this represents the branches that we have for our nested statements. And of course, let's take a look at this, the default, which means that the default statement will be executed if none of these cases have been satisfied. And of course, we also have the break statement, which means for each case, we need to include a corresponding break statement. The purpose of this break statement is for this sequence to get out of our switch whenever it is completed. For instance, if all the statements under case 1 have been executed, then when our compiler sees the break statement, then it will get out of our switch block. Otherwise, it will proceed with the succeeding statements, which is incorrect. So therefore, including a break statement at the end of each case is important and is actually required. Now let's talk about the details of each part of the switch statement. As previously mentioned, we have the controlling statement. A switch statement's controlling statement must return one of these types, a Boolean value or an enumerated constant. It can also be an integer type, which is the case of our example. We are actually using the character. Then the value returned is compared to the constant values after each case, just like what we've seen in our previous example. When a match is found, the code for that case is used, just like this one. Then the break statement. The break statement ends the switch statement. As mentioned a while ago, if we forgot to include the break statement, it will cause our source code to execute the next cases, just like what we have here. What I would like you to do is to experiment with this code. For example, what would happen if you remove the break statements? What would happen if you remove the default statement? I would like you to explore that. Okay, here's another interesting example. We can also do the following. For instance, we can omit a break statement to allow the use of multiple case labels for a section of code, just like this one. Or in the case of D and F, we have the following. While in the case of case A, B, and C, then we can use this so that we can use the same set of statements for lowercase a and lowercase and uppercase a. Therefore, we have the same code whether we enter a lowercase or uppercase. Next, we have the default statement. If no case label has a constant that matches the controlling expression, then the statements following the default label will be executed, just like this one. If there is no default label, nothing happens when the switch statement is executed. Thus, it is a good idea to always include a default section whenever you are using a switch statement. So where do we usually use switch statements and menus? Although if-else statements as well as switch statements might be used for the same purposes and might follow the same logic, but of course, switch statements are best used with menus, especially if your C++ program will require its user to enter a choice based on a given set of options. Nested if-else statements are more versatile than a switch statement under certain scenarios. However, switch statements can make your source code clearer and more organized. For instance, a menu is a natural application for a switch statement, just like this one. Let's take a look at this. Okay, so here's an example of how we can use a switch statement for menus. For instance, our program would require a user to enter a number from 1 to 4. And for each corresponding input, we are going to do the following. It's either we will show the assignment, show his grades, or give hints, or simply end the program. Or in the case where there is an invalid input, then this would be the default statement. For the sake of an example, the following functions have been included, which should be executed, which should be called, depending on the actual input or choice of the user in this switch statement. And here are the definitions for the set functions. In this case, since this is just an example, so we simply place this inside our functions. So let's try running this program. Okay, so for example, let's enter 1. Or let's enter 3. Then finally, I would like to exit the program, so I will enter 4. So that's it. An example of how we use switch statements for menus, just like this one. So what we've seen is an example of function calls in branches. Switch and if-else statements allow the use of multiple statements in a branch. Multiple statements in a branch can make the switch or if-else statement difficult to read, so extra care is needed when we are dealing with such kind of statements in our C++ program. Using function calls, as what we've seen in the previous example, instead of multiple statements, can make the switch or if-else program easier to read. So as you can see here, instead of putting these statements right under this particular case, we can simply put it inside a function just like this one, and that way we will simply put here a function call which would make our program, our source code, easier to read instead of having to put a lengthy set of statements for each case, which would make our program quite difficult to read. For example, if I am going to put this here instead of a program call, this would still run, but of course this would make our program look less organized. So therefore we can simply put that into a function and have this one instead, which looks neat. What about blocks? In C++, each branch of a switch or if-else statement is a separate subtask which can be assigned to a block. If the action of a branch is too simple or to warrant a function call, then we can use multiple statements between braces. Therefore, a block is a section of code enclosed by braces, just like what we've seen in our previous if-else statement. Then, variables declared within a block are therefore local to the block or have the block as their scope. From our previous lesson, especially with functions, I believe we've already dealt with variable scopes and how the scoping of variable affects its value and the way we access the value inside those variables. So therefore, it's always important that we must consider the scope of a variable as well as the block in which a variable exists. Let's take a look at this example which deals with blocks. For instance, we have example 7.8. So here's an example. As you can see here, we have the following variable. As you can see here, this is a demonstration of how we can use local variables within a block, such as this one. So as you can see here, a block is a part of a code which is enclosed with braces. So in this case, this can be considered as a block which is under this particular else if statement. Same also with this one. Same also with this one. And this is an example of a local variable which is scoped only within this block. Okay. So for example, we have the following sample program. For the sake of example, I am going to use the same set of inputs. And in your case, you are free to experiment with whatever input that you would like to provide to this program. Okay. Okay, so that's an example of what our program is going to output given these inputs. So I would like you to try a different set of inputs for this program and see the different outputs that it will produce. Talking more about statement blocks. A statement block is a block that is not a function body or the body of the main part of a program. Statement blocks can be nested in other statement blocks. Also, nesting statement blocks can make code difficult to read if you are not careful. Therefore, it is generally better to create function calls than to nest statement blocks, just like what we did with the switch statement. Instead of putting an entire block under a switch case, we instead place that inside a function and we simply call that function for that particular switch case, which is of course more easier to read as far as our source code is concerned. Then we also have scope rule for nested blocks. If a single identifier is declared as a variable in each of two blocks, one within the other, then these are two different variables within the same name. Although they might share the same variable name, of course, each variable that are declared in different blocks are completely different from each other. And to conclude this section, here's a little practice that you can do by yourself.